Hello, my name is Jess McCoppin, and I am with the Center for Coastal Studies Right Whale Ecology program. I will be presenting my research, which uses vessel-based photo identification data to improve aerial survey abundance estimates. The content of this presentation is not to be shared on social media outlets. For 3 decades, the Center for Coastal Studies has conducted systematic aerial line transect surveys combined with photo identification for North Atlantic right whales in Cape Cod Bay. Additionally, CCS has conducted opportunistic right whale vessel surveys, which provide a unique platform to assess right whale detections missed by aerial surveys. The surveys included in the analysis were from days with both a complete Cape Cod Bay aerial survey and a right whale directed vessel survey in Cape Cod Bay, occurring between January and May. Complete aerial surveys were defined as surveys where track lines 1 through 14 were flown in their entirety. Right whale directed vessel surveys were defined as surveys whose main goal was to document right whales opportunistically as the vessel came upon them. In total, I analyzed 71 pairs of aerial and vessel surveys. The aerial surveys are represented by the transect lines in the left figure, and each vessel survey path is shown in the right figure. For each pair of co-occurring aerial and vessel surveys, I use individual IDs derived from photo identification to quantify individuals detected only from the aircraft, only from the vessel, and from both platforms. The IDs from April 17, 2024 are shown as an example. From this, we can determine the total unique IDs detected from each platform and the combined platforms. I then determine the aerial detection factor, DFA, for each survey pair, which is calculated as a proportion of individuals detected by aircraft relative to both platforms. For April 17th, an aerial detection factor of 0.95 demonstrates that on that day, the aerial platform detected 95% of all individuals detected in Cape Cod Bay. The figure shown here plots the aerial detection factor for each survey pair against the day of the year to visualize patterns of within-season variability. The aerial detection factor was high, with a median of 0.92, and over the 16-year period included in this analysis, the aircraft missed only 189 of the 2,560 unique sightings of individuals, 7.4%. A linear regression applied to the scatter plot shows a slight positive correlation with the day of year, with the highest mean values observed between early April and early May. Although the aerial detection factor was high, I wanted to investigate any patterns in spatial distribution of the missed aerial detections. The figures here present a kernel density distribution of unique sightings of individuals by the aerial platform. Overlaid on the figure are unique sightings of individuals only detected by the vessel, in other words, individuals missed by aerial surveys. These missed aerial detections are generally concentrated in areas of high aerial detection or right whale hotspots, meaning aerial surveys are missing individuals in the same areas they're detecting the most individuals, most obvious here in the eastern part of the bay, where the aircraft detected by far the most unique sightings of individuals. Although this result seems like common sense, this analysis was important in that it proves there was no major right whale hotspots we were missing in our aerial surveys that we detected in our vessel surveys. Dividing this figure into early versus late season, trends in sighting density and spatial distribution become apparent. As compared to the early season on the left, the unique sightings of individuals increase in both number and their spatial use of Cape Cod Bay in the late season shown on the right. Specifically along the western edge of the bay, there are more unique sightings of individuals from the aircraft and more missed aerial sightings, underscoring the observation that aerial surveys are missing individuals in these right whale hotspots. Understanding these temporal and spatial patterns in missed aerial detections is useful for refining North Atlantic right whale abundance estimates and informing conservation management strategies to better understand how detectability changes throughout the winter and early spring in Cape Cod Bay. Although this analysis cannot speak to the overall efficacy of our aerial transect surveys, our high aerial detection factor confirms that aerial surveys are detecting almost all the individuals detected by CCS platforms surveying for right whales in Cape Cod Bay. Additionally, the analysis demonstrates that when the goal is to document every individual, having a second platform in addition to the aircraft is helpful, especially in those right whale hotspots. Our ongoing work focuses on further exploring the underlying factors influencing right whale detectability, including sighting conditions and whale behavior. Additionally, I plan to increase the number of survey pairs in this analysis by including incomplete aerial surveys of Cape Cod Bay, as long as the aerial survey encompasses the vessel's path. Thank you to the consortium for allowing me to present, to our funding sources, and to my co-authors.